Did somebody ask what time it is? It's crankshaft time. Ugh, this is a really stupid joke. I think I'm going to cut this. Hello, Internet. My name is Quinn, and this is Blondihacks. Today we're making the crankshaft for my PM1 model steam engine. I've never made a crankshaft before, but it's a pretty involved and very interesting process. So let's go. Strategy time again. Now, machining crankshafts is kind of an art unto itself. I've got a book I'll recommend on the subject called The Amateur's Lathe. It's got a little section in it specifically on machining crankshafts, and it demonstrates, I think, 3 or 4 different techniques for doing it that are all really interesting and really great. None of which we're going to use here because this style of solid one-piece cast crankshaft demands a different technique. But these all boil down to basically the same thing. You need to find a way to machine the main shafts here, and they need to be machined between centers, at least for the final pass, so that everything is perfectly concentric here. That's super important on a crankshaft. And then you need to find a way to fixture it offset so that the journal area is on the center of your lathe so that you can machine that perfectly concentric. And then sometimes people machine the offset links themselves. Some people don't, it depends on the style of the crankshaft. And crankshafts are very often made from separate pieces that are bonded together in some way. But this cast piece has this web in the middle, which we're going to leave intact because that's going to allow us to support it in the lathe like this for the initial machining. And then the drawings that come with the engine suggest this helpful little jig for turning the journal. And that seems like quite a good idea. I may well do that. Okay, let's give this a shot. I'm going to start by cleaning up this casting with the Dremel as much as I can. I'm trying to avoid too much interrupted cutting here on this part. Next, I'm going to set it up in the forejaw if I can, and I'm going to try to face the ends here. So I think I have just enough room on the forejaw to get the offset needed. The crank web does not fit inside the bore on my lathe, so it has to be held just in the jaws, but that looks like that's going to work. Now this is a lot of stick out here, but I'll see if I can get away with it. Because it's a rough casting, I can't use a steady rest or anything very easily, although I do have a cat's head. But this seems to be working, so we'll press on here. And these are light cuts, and that's helping. Got a little nub in there. My tool height isn't quite perfect. Now, since I have it set up like this, I want to see if maybe I can put a center in it while I have it here. And it's fairly well centered, so I think I can get away with it. And I'm just checking to see if it's straight as well, and it looks okay. So I went ahead and put a number 2 center in there. And I'm just measuring to make sure that the smallest distance is still going to be within the dimension that we need for the crankshaft. And it looks like it will be, so we got away with that. That's good news. So I did the same thing on the other end. I faced and center drilled that, and now I'm setting up with the center in my spindle to turn between centers. The plans actually suggest roughing in the crankshaft in the chuck and then just turning between centers to finish it up to final dimension, but I didn't really see the point of that. I mean, I had a setup there that might have worked for that, but I thought I might as well just turn the whole thing between centers, and so that's what I decided to do. I'm just spinning it up here to see how much vibration there is, and there is a fair bit. We've made a giant cell phone vibration motor here, so I'm adding some counterweights between the crank web and the lathe drive pin there. There's a fair bit of off-center mass swinging around, and on tiny little lathes like this, that's quite a problem. So with this setup reasonably well balanced, I can get it up to about 400 RPM, which is sort of just enough to where I think we can turn this. Now, I started out using this sharp-nosed tool here because it allows me to get in really close to the live center there. And this is working okay. It's obviously a very interrupted cut. The challenge that we have here is normally with a casting, you want to take a first cut that's deep enough to get under the scale on the outside of the casting, because that scale is really hard. But there really isn't enough rigidity here, nor do we have very much material to remove, so I don't want to risk taking deep cuts. So I'm having to just kind of chisel my way through that scale on the outside, which is not going super well, and as you can see, it's blunting my tool quite frequently. So I wasn't getting good surface finishes, and I was getting concerned. So I stopped here and I did some polishing with the 320 grit emery cloth just to make sure that I was going to be able to get a good finish before I get too close to my dimension in case I have to change strategies here. But the finish came out good after that polishing, so I decided to press on with this tool, knowing that I would need to do a fair amount of polishing as I got close to the end. So I machined that down to within 1 thou of final dimension and then flipped it around and did the same thing on the other end. The beauty of turning between centers, of course, is that you can flip the part end for end and not lose your concentricity. On the other end here, you can see I'm using a different tool. This is actually my normal turning tool that I use for steel, and I just ground the back corner of it off so that I can get closer to the live center, and this tool is working much, much better. It's got a much more robust tip on it, and it's cutting through that scale no problem, and actually leaving a nicer finish as well. Here on the Blair Witch Cam, you can see how exciting this turning setup is. There's nothing dull when turning crankshafts, I've learned. And I made sure to chamfer both ends while we have the chance here. So I should be 1 thou oversized now, and I'm mapping out each end of the shaft in 3 places just to see exactly where any high spots are, see if there's any taper anywhere, and then I'm taking out that last thousandth entirely with emery paper. And this takes a little while, but it gives you really good control over exactly where the material is coming off, and it gives you plenty of time to check your dimensions in multiple places, make sure you're not introducing any taper, and so forth. I wanted to come in a little under 375, and so we're at 374 and 7/10, so I think I'm going to stop there. That's really quite good, and I've got that same measurement within a tenth on 3 places on the entire length of this shaft. So a little test fit here in the main bearings, and that is an excellent, excellent fit. That spins freely, but there's no slop, and I'm really happy with that. So I flip it around, and then I do that same polishing procedure on the other side, and I'm aiming for that same dimension of 374 and 7/10. And the great thing about this polishing method is after that test fit, if I decided, I really need to take another 4 5/10 out of it, you can easily do that with the polishing. It really is amazing what a fine shine you can get on cast iron. You'd think, being such a gritty and rough material when you start, you wouldn't think that you could get it to this kind of high mirror finish, but it really does polish up just beautifully. It feels like glass, and it's really not difficult, just 320 grit paper and some patience. All right, there's lots more work to do on this crankshaft yet, but I couldn't resist a test fit now that I have the 2 shafts turned. And that seemed to go in there nice, but then the bearing caps didn't fit, and I thought, well, that's odd. Well, look at this. The shaft slides in from the end, just as it did when I did the test fit over on the lathe, but we can't push it in from above. If you look closely at the end, you can see what's happening. The bearings are bored ever so slightly below the center line of the bearing cap split there. And we're only talking 4 5 thousandths here, but that's just enough to where there's more than half a circle below the center line. So it's an easy fix. I just have to chamfer those top edges a little bit because it was very, very close, but it's a pretty amusing effect of a high precision boring and turning operation that I would not have anticipated. So after a little bit of chamfering there, then now that shaft pops in there beautifully and spins very nice. So we'll try those bearing caps on there again. A little test spin. Oh boy. Oh, that spins really, really nice. There's just the slightest hint of a tight spot on about 10 degrees of the spin. I think that will probably run in once the engine is running, but wow, I'm really, really happy with that. And I couldn't resist. I had to put the tenths indicator on it, and we've got maybe 2/10 of run out there, so really hard to complain about that. And that's not me. I mean, that's just the power of turning between centers. Now, you might be wondering what is supposed to locate the crankshaft horizontally. There's these little gaps there, and the crankshaft can slide back and forth. Well, this is the point where I wondered that too. So I went and looked at the drawings, and whoops, I was actually supposed to leave a shoulder in there next to the crank webs to locate the crankshaft horizontally. That's okay though. I have a solution for that, which I'll show you later in this video. But while I have it out, I thought this would be a good time to face the sides of the crank webs here. This is kind of a difficult part to hold at this point. There was really no way I could think of to fixture it in the vise, so I used my toolmaker's clamp and bolted the clamp down to a 1-2-3 block, and this seemed to work quite well. This wasn't the most rigid setup because the toolmaker's clamp is gripping on the rough casting and it's not very even, so the grip isn't very good. So there was some vibration there, but it actually worked okay as long as I took it easy. And you can see there are some inclusions in the casting here. I have to say the casting on this crankshaft is probably among the worst that I've seen so far in this kit. I'm guessing it's because this is a difficult part to cast. It's very intricate, but I do like the look of the finished crank webs, so I'm going to continue and finish all the other sides here as well. I'm about 10 thou under size here, and there just wasn't enough casting there to face off, and I'll talk more about that in a minute. But next, it's time to start work on this fixture that the drawing suggested. And I'm going to make it as shown here, but with a few modifications, because among other things, their design assumes that the entire crank web will fit inside your spindle bore, and I'm going to add one layer of functionality to this jig here. Over to the junk pile to see what I've got to make that out of. I'm looking for some steel, some cold rolled. Now this is the garbage steel that you may have seen in my cat's head video, but easy, careful, dip, nip, yep, okay. Everything's okay. Just put my security theater strap back on and over to the bandsaw to cut this to length. And for some reason I cut it twice as long as it needed to be, so I cut it down again and faced it off on the lathe. Now you can see I'm using a carbide tool here, which is not something you see me do a lot of, but this is some mystery garbage steel, and carbide does a much better job with this than my high-speed steel tools do. This is a brand new Kennametal insert. It's doing very, very well. And the finish on that is actually not bad, especially considering the terrible quality of this steel, but I am going to polish it up a little bit because I'm going to need to do a lot of indicating on this fixture, and a better surface finish really helps with that. So still some tool marks there, but it's smooth to the touch, which is going to do for what we need. So now I just flipped it around and turned the other end and polished it to the same diameter. Then I chamfered the end and I set up to drill a through hole all the way down the middle. And this is the first deviation that I'm doing from the suggested fixture, and this will make sense here in a moment. So I'm center drilling that, and then I'm drilling straight through one size under 375, which is what the crankshaft shafts are, as you may recall. And then I'm reaming that to 375. So this is going to be about 3 or 4 tenths larger than the crankshaft. And so that crankshaft should slide perfectly in there, and boy does it ever. That is a beautiful, lovely fit. Over to the mill now, and I'm edge finding on the jaws there to get the center line, and I'm going to mill a slot all the way down this side. Now this is just like the suggested fixture in the plans, and what this slot does is it holds one leg of the crankshaft offset, so that the journal on the crankshaft becomes centered on the lathe axis, and this is what allows you to turn the journal. And the finish in that slot is rubbish. I started out with this cheap end mill, and I just always regret using cheap end mills, so I swapped in this Niagara cutter that was donated to the channel, and just night and day difference. The finish on that is beautiful. I've said it before, but end mill cutters are a place where you really do get what you pay for. I have regretted every single cheap end mill that I've ever bought, and these really nice ones I never regret. So if there's one place in a hobby shop you want to spend some money, make it your end mills. Now the depth of this slot is really critical because it has to be such that when the crankshaft is sitting in there, the journal is the exact offset such that you get the throw that you want from the center of the journal to the center of the legs of the crankshaft, if you will. So that's really important. I did a bunch of math to figure out what that should be, but to double check it, I'm measuring across an end mill here that's 375 and a drill that happens to fit in that slot. And I mic'd the end mill and the drill, so I'm accounting for the differences in diameter there. Like the drill is 1 thou undersize, the end mill is 1/2 thou undersize, and that looks to be right on. So I'm really happy with that. I also double checked it with a depth mic against the math that I had done, and that also looks correct. So now I can widen out the slot to the final width needed for the crankshaft. I didn't try to cut it the final width in one pass, because when you cut a slot with an end mill of the same width that you want, the slot always ends up a little bit oversized. So I do a smaller pass down the middle, and then it's really easy to go plus or minus 10 thou on either side to widen it out to the final dimension. A little cleanup and some deburring to do a final test fit, and you can see here what a nice finish that cutter left. Hashtag not sponsored, but boy, I sure do love Niagara cutters. So here's a 375 end mill, and that fits just exactly the way I hoped it would. So far, so good. The real moment of truth, though, how does our crankshaft fit? And woof, perfect. Boy, I love it when a plan comes together. And one more check with another pair of end mills to make really sure that that throw is going to come out right, because this is our last chance to fix it if it isn't. but it all looks good. So setting it up vertically now, and I need to cut a slot down the top that matches the one down the side. So I'm tapping it in to get it really nice and vertical. Now I have to get the slot oriented with the y-axis of the mill, which is a little difficult to do. So this janky setup with the tense indicator seemed to work okay. And then I lined up the hole in the center using my edge finder, which happens to be exactly 375 in diameter. I also set up a machinist jack on the other side of the vise just to balance out the clamping a little bit there, because we're kind of all off to one side here. And now I can go ahead and mill this slot down the center. And once again, I'm milling it a little bit undersized, and then I'll widen it out at the end. This time I'm using a 2-flute end mill, or as the Brits would call it, a slot drill. And well, it's called that for a reason, because it's good for making slots, I suppose. So I don't usually use 2-fluted end mills in steel, but I thought I'd give it a shot, and this actually seems to be working quite well. So I widened it out to the final width. The depth on this guy is quite a bit less critical. It just needs to hold the crank web for the operations that are to come. So I deburred that in preparation for a test fit, and that is lovely. So you can see how it's going to suspend the crank web there so we can machine it. And now I lay it down on its side, and I'm just getting it level here by tapping on my scriber and indicating in that surface. This isn't super critical. I think I got it within 1/1000th, and that was fine, because all I'm going to do here is mill some flats for some set screws. And I just busted out the roughing and mill this time for speed. I can take twice as much of a depth of cut here, and I don't care about the finish on the side of the surface there. And then I just eyeballed a center line for a set screw, and then I just put 2 more on either side, same distance apart. Spotted all 3 of those, and then I drilled for the tapping size, and I just drilled these all the way through so that we're going to have 6 set screws total. And then I tapped them 632, and I chose that size just because, well, it was a good fit, but I also happen to have some brass-tipped set screws from a previous project that are that size, and those would be a really good choice here. So you can see how those are all brass tipped so they can clamp on our machined surfaces without damaging them. And here you can see how that's going to allow me to machine the sides of the crank webs there, and then I can flip it around and install the crankshaft thusly, and then that puts the journal on center in the lathe, and so we'll be able to spin that up and turn the journal thusly. So this fixture has 2 purposes, more than just the one suggested in the drawing, and I'm pretty happy with it. So let's set this guy up in the lathe and give it a whirl, so to speak. So I dialed it in such that the crank itself is running true, which, you know, the fixture might be a little off of true, but that's okay. And I started by facing the outside of the outer crank web there. And this is always a kind of a funny thing. It's hard to tell that anything is happening because the crank web is such a small portion of the rotation that it feels like you're not doing anything, but when you stop it, there it is, you can see your progress. So a couple more passes and we are looking good there. There's still a couple of small inclusions there, but I don't want to get too crazy here because I don't have a lot of material to play with, but with that side cleaned up, now I can flip it over and clean up the other side the same way. Okay, so far so good. It's far from perfect. You can see some tool marks and stuff in there, but I'm pretty pleased with that so far. Now, I think we've done all that we can with that little web in place, so it's time to cut that out of there. And I thought I'd build some character and use the hacksaw, and after about 5 minutes of that, I decided maybe I have enough character, and I switched to the Dremel and knocked it out of there. And now it is officially a crankshaft. So I thought this was a good opportunity to go over to the mill and clean up some of the remaining outer surfaces. And so I milled both sides of the crank webs and also put a chamfer on one end as called for in the drawing. This helps a little bit with clearance around the base casting and also looks nice, makes it look very crankshafty. And so far so good. Again, some of the finishes aren't awesome in there just because there's inclusions and the casting wasn't really thick enough in a couple spots. When I was using this fixture earlier, I noticed that it was missing something. It really needs a counter bore at the end of the center bore there to accommodate the end of each of the crank legs to allow the crank web to seat tightly in the recess there, and that really fits in there nicely now, so that's what it needed, and that's going to allow me to machine the insides of these crank webs much more effectively. Now here comes the really clever part of this fixture suggested by the drawing. one of the vice jaws there with the copper on it clamps on the leg of the crankshaft, as you can see there, and holds it in that slot. So the crankshaft is held firmly, and this setup is really repeatable, so you can remove the crankshaft if you need to. And I'm ready to turn the insides of the crank web, so I'm going to need some small turning tools to get in there. So I've got some small chunks of high-speed steel here, and I'm going to turn some left and right hand turning tools. I'm not sure what's going to work the best here. So over to the grinder for that. Obligatory stone hone, a little bit of a nose radius, and that looks good. That's my left-hand turning tool there. Now I'm a little bit concerned about the rigidity of these tool bits because they're so small, so I put some scraps of high-speed steel under them that are narrower for a little support, and I think this might work. I also set up an indicator so I know exactly how close I can get to the inside of the journal there. It would be very, very bad if this crankshaft hit the tool post on my way in, so I was very mindful of that. And then I just worked my way in nice and slow, turning the inside of the crank web there, and I have to say that worked out pretty well. It was slow going because it's obviously an interrupted cut, and again, that tough casting scale, but that worked okay. So now I just flipped it around so I could do the other side. I considered just using my left-hand turning tool to do the other side where it was, but the outer crank web is quite a bit less rigid than the inner one is, so flipping it was more desirable. And in case there's any doubt about how repeatable this fixture is, check out that indicator. Hard to argue with that. Whoever designed this fixture, I want to say thank you because it's very, very clever. I went in and cleaned up that other crank web, and then it was time for some measurements. A little difficult to get in here around all of the many indicators that are precisely set up to tell me exactly where I'm going to die. But these two crank webs are both at 305 thousandths thick. Now, the distance between them, however, is 370, so I need 440 between them. Now, the overall width is supposed to be 1 inch across the outside, and I happen to know I'm about 20 thou narrow there because there just wasn't enough casting material to clean up the outsides. The drawing specifically says that cleaning up the casting on all sides is an option. They say, you know, remove minimal material, but you can do that. There really wasn't enough casting material to do that because by the time I now get this widened out to 440 in the middle, my crank webs are going to be 10 or 15 thou undersize each. So I think that's going to be okay. We'll just lower the horsepower rating of the engine by 5%. Now the width of the connecting rod is 435 on the drawing. So I could leave this where it is, let's say, or, you know, open these up, say another 10 thou instead of the 25 thou on each side that's required, and, you know, cheat the connecting rod down 10 or 20 thou, something like that. But I don't want to start going down a road of cheating every dimension undersize all the way down the chain of the mechanism, because 2 or 3 parts down the road, I'm going to forget where I am and lose track of what size things are supposed to be. So because being 10 thou undersize on these crank webs is going to be just fine, I'm going to stop the error here. So I'm going to make this 440 inside, and then everything else from here down is going to be correct. A couple more passes, and I can confirm my final width here with the adjustable parallels, and we are right where I was hoping to be. So now I need a tool to turn that journal. So here's what I ground up. It's kind of like a parting tool, but it's wider for rigidity, and it's got clearance down both sides, and then an end clearance, and then a back rake on the top, appropriate for steel and cast iron. And I used a light and my Starrett square to make sure the end of that is as square as I can get it. Now I'll stop and point out here that technically there should be clearances ground in all the way down the sides of this tool to clear the entire crank web, but I didn't want to pay the price in rigidity that I would for doing that, so I have not clearanced the entire sides, and I'll just stop a couple thou short of both sides of the journal, and then I'll clean that up with a sharp nose tool at the end. I gave this tool a little test drive, and it's really not working great. It's struggling to get through that casting scale on the outside. So I thought I'd give my parting blade a try, but that's also really not working. The blade is flapping back and forth too much, doesn't have enough lateral rigidity. So I really needed to reduce tool pressure. That's what this boils down to, just to get through this crust. So I brought back in the turning tools that I made, the left and the right hand, and I just very carefully turned down the scale to get down to the cast iron. That left a little strip in the middle that I couldn't reach, but we'll come back for that. So now I'm back to my shearing tool, and I'm using a light and the side of my fixture to square it up as best I can. And then I should be able to come back in and just clean up that strip there in the middle. It's really critical that that tool be square to the work, otherwise we'll actually create a taper in the journal because the journal is so narrow. And this actually seems to be working okay. It's a little bit slow going to get through that scale, but once we're past the scale, this tool is making a really nice chip, as you can see here. So this actually is working really well. It just couldn't cope with that crusty cast iron outer coating. So with this tool, I was able to plunge in a ways on one side of the journal and then move over and bring the other journal to the same depth. And then, as I said, I couldn't get quite into the corners, so then I came back in with my turning tools and cleaned up those inside corners. However, while I was doing this, I was noticing a wobble in the journal. So I put an indicator on it, and look at that. Got about 8 thou run out there. It took me a while to figure out what was going on, but luckily I hadn't gotten very close to my final dimension yet. Note that the leg of the crankshaft is only being held in place by the jaw at the far end, and at the leading end there's nothing really holding it except the friction of the set screws, and they weren't enough to resist the cutting forces pushing away on the far side of the rotation. This is partly because my fixture is a little different than the one in the plans, and this is because, again, my lathe is too small for the crank web to fit through the bore, and so I had to make this fixture a lot longer than the one that's specified. So it really needs something to hold the outboard end of the crankshaft leg there. So I got out my precision hose clamps and a piece of brass and clamped it down, and that did the trick. And once again, I polished it down to final dimension, and we're aiming for 374 on this. And we came in at 374 and 2/10. So I'm going to leave it right there. I think I'm happy with that. The finish on that is excellent. Once again, that cast iron just polishes up so beautifully. And now I can remove that Precision Machinist's hose clamp. And thank you, Mr. Fixture. We are done with you. You served us extremely well on this little project. Okay, time for another test fit of the basically done crankshaft. Make sure that still fits in there. A little bit of oily oil. And, oh boy, that spins so nicely. I just love that. I could do this all day. In fact, sometimes I do it all day. Look, there's a pandemic, okay? I don't have a lot else to do. And with that, my little steam engine finally has moving parts. I remember that horizontal alignment problem? Well, I just turned up some little rings out of 932 bearing bronze and filled in the little spaces there on the sides. And now that fits in there beautifully, and there's no side play, and it still spins great. So a little bit of bling on there, never hurt. That's my little crankshaft. I'm really happy with how it turned out. You know, it's far from perfect, but it's amazing to me that you can take such a gnarly, rough-looking casting and turn it into something so beautiful and so functional. That's what I love about machining. I hope you enjoyed watching this. If you like what I'm doing, throw me some love on Patreon, and we'll see you next time.